I'll just get started. I'll let you guys introduce yourself.
Sure. My name is Nand Mulchandani. I'm the CTO at the Joint Artificial Intelligence Center. Just joined the DoD about 3 months ago. Had a 25-plus year career in Silicon Valley. Built and sold 4 companies in the cybersecurity and enterprise infrastructure space, but decided to come in and join the government and do some public service.
Okay. You?
I'm Vettel. I'm a neuroscientist from the U.S. Army Research Laboratory, and I do a lot of work on developing adaptive technologies where we use, as we'll talk about, I'm sure, artificial intelligence-like approaches for having technology can actually adapt to humans, to soldiers, based on our physiology response.
Oh, wow, okay.
I'm Brian Drake. I'm with the Defense Intelligence Agency. I work in our Science and Technology Directorate, and I direct the artificial intelligence portfolio of the agency.
Okay, here's my first question. Where do you guys see the biggest use cases of artificial intelligence in government? And what are the roadblocks and challenges of that particular issue? I'll start with you.
Okay, great.
Go left to right.
So I don't know if everyone's familiar with the JAIC, but the JAIC was stood up by Congress last year to help oversee and become a center of excellence for AI work across the DoD. We have an expanding line of work basically across AI, different disciplines. So we started out with 2, which was predictive maintenance on our equipment, making sure that operationally and also did cost management on maintenance. The other one was humanitarian assistance, disaster relief, which is actually a real crowd favorite, focused on helping FEMA and other agencies do firefighting, waterline detection. We've added 4 new ones: warfighter health, cybersecurity, RPA, which is business intelligence. And the last one, which is actually a DoD-specific one, is joint warfighting, which is applying AI techniques to, end-user capabilities for the warfighter. So that should be at least a good map of what. Under each of these 6, we have multiple product lines that we're actually delivering. So if you're interested, you can I can go through them at some point.
Okay, Dr. G.
I think it'd be helpful in our conversation to introduce a concept of weak AI versus strong AI, just because sometimes people think that what we're interested in is in mind reading, and we're not. And so I think if we talk a little bit on the panel about weak AI, you guys can pick if you want a different example, but you can pick weak AI as, I don't know, and the algorithms that tell you which Netflix shows you want to show. They mine your data and tell you something about what you like, right? It could be algorithms that tell you which way to navigate. Any of these things, most people don't consider much of an invasion of their privacy, but it is an algorithm that is analyzing your data and giving you something customized to yourself. I'm going to pause to see if either of you want to debate or...
No, I debate. The analogy that I'd bring to that is in cybersecurity, there's the issue around false positive, false negatives. And it really, there's a direct analog to strong and weak AI in many cases. And I think the previous speaker was talking about this loan example, which I think is a great, this issue of thresholding and being able to do decision making off of that is very key. But please.
Sorry. No, this is good. I like discussion. So as long as you don't mind, I'm going to try to
fine.
break a little bit.
I like it.
Lose control of the panel.
It's okay.
But Gene, you're hitting on something that's important in this discussion for all of these forums that we have, is definitions become really important. Because when we have these conversations about particular capabilities we're making investments in, you say AI, I say AI, you say machine learning, I say machine learning.
Sure.
It means different things to different people in different ways in different contexts. So it's a very nice way of bifurcating it, and we have examples we can share in both camps. So.
And so then, just to put on the other side, the strong AI, you can pick your favorite science fiction character that you like. I usually pick things from the 90s or the 80s, so like Data and Star Trek or Terminator. Anyone have anything more recent? I live under a rock, so I'm kind of out. But
those are really good ones.
Okay. But anyways, in that case, right there, the idea is that it's like the Turing test. We now have a piece of AI that is confusable with another human being. Okay, so if we put those as the extreme, then essentially what our research works on is, first, in contrast to most of the conversation that happened today so far, my research means that I'm intentionally focused on what AI can do in 2030 and beyond. So a lot of what we heard today is what we're trying to do with machine learning or artificial intelligence for answering business questions sort of in nearer timeframes. But just to understand everything that I'm saying, most of it is focused on what we call the deep future, the many years from now. And one of the things that we have envisioned in that time frame for what some is in the middle ground between what I just tried to define as weak AI and strong AI is, I'm going to call it, I don't know, I'm just making this up on the spot, so that's a probably terrible idea, but I'm going to call it teammate AI.
What was that again?
Teammate.
Okay,
AI.
all right. I like that.
And here's what I mean by teammate AI. I think I lost my mic. I guess you didn't like that. And she's done.
We can hear that.
Sorry. Is that what we would like is to have a piece of technology, so it doesn't have to be AI, but we want a piece of technology, a system that a soldier can interact with, and have the ability for bidirectional exchange of the current information and certainty about the world that the human has with the certainty and confidence that the piece of technology has about the world. And we want, in terms of the last conversation, I would start evolving this idea of what it means to be explainable AI, but you would want to have the ability that the technology can start anticipating something about what the soldier wants, just like if we interacted for a long time, right? We may start being able to anticipate a little bit of what our fellow human teammate will do. Mm-hmm. Are you with me? Right? Because if you're in a good team, let me pause. If you're in a good team at work or good relationships, mm-hmm. then what's nice about that is that the other person becomes somewhat predictable. You're not shocked by, oh my gosh, I can't believe they just did that, right? Or you don't get annoyed that your AI just auto-corrected something completely reasonable and something completely unreasonable that you're about to send to someone, right? And if what we essentially work on is, can we use physiology, so all of a human's performance, behavior, a soldier's, any of us, right, performing something, it's all the result of our internal physiology. It's some neurochemical interactions within our body that produces a behavior. Mm-hmm. And so we ask the fundamental question, do we currently have a sufficient imaging technologies to image my physiology in the environmental context sufficiently so that I become predictable? Oh. And if we can do that, then what can we do? We can define algorithms, AI or ML or something else, causal, multivariate methods, anything. I'm not committed to AI, ML. I hope I can still sit on this stage. But we can say, can we then use that information about the human to make the human predictable for the AI to adapt to, rather than just saying, oh, we don't know. Humans average about this. Let's make a piece of technology to do that. So that's where we sit in the middle. And did I talk long enough? I'm sorry.
No, it's okay. It's fine. I love this. This is good stuff. Brian, what do you think about that?
Yeah, it's great. So at the Defense Intelligence Agency, we've made numerous investments in artificial intelligence, 2 programs that we work on that are unclassified and can be disclosed publicly. One is called Sable Spear, which is a counter-opioid project that we worked on to focus on the health crisis abroad. DIA's charter is to focus on foreign threats, so it was not focused on the health crisis within the American borders, but it's focused on sources of where fentanyl originates and how it comes into the United States. So in that example, using the simplistic or whatever.
Continuum.
Yeah, the continuum. It was considerably more complex because it was multiple AI jobs being run against very unlike data sets to create data correlations to then derive a discrete insight. So consider, for example, we might have images, we have text, we've got documents, and each of those have to be exploited in a very specific way. And prior to even getting to the exploitation part, the machine has to recognize, that's a document, that's a picture, and so forth. So our vendors took that problem set on and then got us down to discrete results to say, I can tell you down to the person who is in charge of this particular factory in a given country who is producing illegal fentanyl. And so from that, we can trace it back into the United States, pass it to a law enforcement partner and say, this has to get action, right? So that's more of our counter-narcotics portfolio. Then we have another program, which is our future environment for analytics, which is called the MARS program, Machine-Assisted, I'll slow down for this one, Machine-Assisted Analytic Rapid Repository System, MARS. So we just said MARS. That environment is where we intend to host data, machine analytics, any type of mission-facing solution that we want to deliver to warfighters so that we can prevent and fight wars. So some of the challenges that come along with that are, these are ambitious, right? These are big projects for us to do. The data that we receive is very unlike what you might see in the commercial space. So we have to balance the sources and methods way of which we collect information and then process that into a unique insight that you don't just read in the Washington Post. So I like to use this analogy just to kind of scope everyone's understanding of it. So imagine you're a puzzle, you love puzzles, but you're cheap. So you go to a dollar store and you buy a puzzle that's missing some pieces and it lost the box top. But you love puzzles, so you get it at a discount, you take it home, you start scattering those puzzle pieces, right? And you start putting together a picture. And then I start looking at it and I say to Jean, hey, Jean, this looks like this is a picture of a ship. And she'll look at it and say, no way, it's a ski jump. Okay, our perspectives are very, very different. So we'll start taking the puzzle pieces and interrogating them. How do you know that puzzle piece is telling you the truth? How do you know that? How do you demonstrate that to me? Is this a human source that's telling me this? Is this a technical source that's telling me this? There's degrees of confidence we ascribe to that. So now we understand the puzzle pieces. Now we debate, okay, now what's the picture if we understand the puzzle pieces? In our world, the challenge is the puzzle pieces are getting much, much more voluminous. So it's not, the problem in the Cold War was we don't have enough puzzle pieces. Now we got too many puzzle pieces. So how are we going to go processing through those puzzle pieces to derive insights and jettison things that we don't care about or are not within our authorities or whatever?
And so how does that relate to what you said you're doing for joint warfighting?
So we specifically don't cross over into intelligence work. A lot of our joint warfighting work is focused on things like command and control systems, drones, a number of other things. Project Maven, which is also very closely associated with Jake. General Shanahan, who's the current director of the Jake, was running Maven before. Really, the intersection. So there are two big sort of differences to generalizing this. So the work that you're doing seems, obviously 30 years in advance. We're actually completely the other side. The Jake's focus, unlike DARPA or work that you might be doing, is completely focused on here and now. How do we take mature technologies from industry and get them deployed in production now? And so we don't stray into R&D, we don't stray into speculative, other pieces there. It's purely about the D side as opposed to R. So therefore, any of the joint warfighting work that we're doing is really focused on taking systems that are either in place and AI enabling them. And there's a whole discussion to be had about that. Okay. My 3 months at the DoD, one of the biggest shocks to me is what I call the snowflake application problem. Is just the single purpose applications that just clutter the entire landscape of software. And in Silicon Valley, one of the big shifts that we've made, and sort of tying this back to the theme of data, is that the entire lens for me for data actually comes through applications. Because building applications or systems that talk directly to data is actually a big mistake. You really do have to put a layer on top of it of an application interface or some system that gets you to the data. The problem with the snowflake application problem is there are hundreds and hundreds of these out there. And for AI, as we all well know, you really do need a platform-centric way of looking at the data, getting at the data, as opposed to building systems on top that go after this sort of multitude of apps. So that's one of the problems that we're actually having to solve before we even get to AI. So that's actually the big insight is we're called the Joint Artificial Intelligence Center. We should be called Get the Data Cleaned Up First Center before we get to the Joint AI
What's that acronym?
stuff. I don't know. CLEANUP maybe.
Okay, pretty good. That's good. You guys want to expound on that or want me to go on?
Yeah, so this is kind of beyond my purview, but the programs that we partner up with in the Maven program are part of the DIA Intelligence Enterprise, and so the imagery or any other processing that goes along with that, we're very closely partnered in that regard. So it's a little more transparent at my level. We operate more like a venture capital outfit, so we identify problems in the enterprise, as Dr. Copper was talking about, and from those problems, we then start to unpackage, does it fit into an AI solution, which is an interesting conversation to have because you start to discover that they have a real problem, it's just not a problem I can solve. So it might be something I pass off to another colleague to operate. And then we try to pair them up with an innovative contracting resource that can find a way to expedite the move from an idea into something we can actually test against a real mission problem.
Yeah.
Okay. All right, let's talk about back-end processes for artificial intelligence. One of the questions is how agencies should collect and store and process their data for artificial intelligence programs for success. I guess every one of yours are different, so I'll let you expound on that based on your environment.
Do you want to go first?
You want to go first? Man.
How do we position? Well, it starts with that. It starts with identifying the problem. Like and usually it has to be a problem that has some weight. If you are trying to fix, I'm sorry, I can't think of something that's a simple problem. Let's just say that we were trying to fix, how we do end-of-year evaluations, and it was, we want to make it faster or something like that. That's probably not something that would come to me. That's probably a business process that needs to get refined somewhere else. And I think every agency probably has some sort of challenge in that regard. A problem that would come to me that I would care about is something like I've got stacks and stacks of invoices, and it takes 2 weeks solid for us to process those invoices to pay our contractors. Okay, that is for a simple AI solution, that'd be great to automate so that we can start to say, I can process those invoices now, I can just pull out little bits and pieces to say, here's how much it is, here's the address, let's write the envelope, here's write the check, boom, done. And so now I've started to make a process that takes 20 people to do. I'm making these numbers up, but 20 people to do, now it's down to 1 or 2 people, right? But those might be my best, most qualified people to do that, and I could repurpose the other folks to do something else. And I think this is a part that gets lost in the discussion, is that I think there's a fear that when we deploy these AI solutions that we're going to start firing people. I don't foresee that future at all, because what I do foresee is that the demands on the workforce and the talent that we're going to need is going to be very different, and it's going to be folks that have exquisite skills in very specific areas, and it'll be augmenting work. It will not be replacement work.
Yeah, we actually have a similar question all the time that asks if we essentially are trying to get technology that will essentially replace the skills or capabilities or expertise of a soldier, and the answer is always no. That's, in my opinion, that's impossible, right? Because all it is, to your point, it's just a shift in what is it that a person will do versus what a piece of technology will do. And not to propagate the I think, emphasis that people have on image labeling as what AI can do, but in the near term, that is what AI does really well. It can process large pieces of information more efficiently than a human brain can actually look at those images.
Right.
But if you take a soldier example where, because humans will always be fighting other humans, right? Humans, if the IEDs are always getting placed in this particular, in dead animals or something, was the example from Afghanistan, then the counterinsurgency is going to know, we need to look for images that have animals. Well, then as soon as you efficiently can't have a successful attack with animals, you're going to change it. Then it's going to go behind posters. Well, then the trick is that we focus on how is it that we can then say a human soldier could, in split seconds, right, start looking for the right thing in the images because they have that expertise. But algorithms are very rigid or brittle, and they cannot. And so a lot of what we try to do is say, okay, if you were to think of collecting physiology on a group of soldiers that are successfully analyzing the security or the threats of a region, and you overall could say, okay, these soldiers over here seem to be identifying different things as threat than these soldiers over here, all from our physiology. We're not having a conversation about it, right? It's not like the last speaker was talking about, you're not trying to break their expertise of what are you looking for, make it explicit. They're just understanding like, no, the threat seems to be changing over here. I'm overall getting a detection of something different. You can then use these soldiers, the fact that they're looking at different sets of images as being labeled as a target, and then take that, feed that back to the algorithm, rapidly retrain the algorithm, and that's how you take expertise and you put it back into the system efficiently, and you never have to have people talk, right? It's all based on the physiology response.
Interesting. There are 2 or 3 big things, at least, we're dealing with, sort of around that, but I think more tactical. Number one is one of the biggest issues that we're facing when it comes to dealing with AI work, and I had a long conversation just the other day with one of our Army colonels about this, is moving from what we think of as somewhat deterministic decision making to probabilistic decision making is one of the biggest jumps that our systems are going to have to make here. Now, not to say, when you actually dig deep into it, the current systems actually still have probabilistic decision making actually baked into them in the code. When you actually think of thresholding, when you think of writing a piece of software that spits out a decision of some form today, the coder or the business owner of that application has effectively coded in some policy decisions into it that have thresholding already baked in. What AI is now starting to do with the systems that we're developing and deploying, and all of us are doing that, and everyone here, is that all of a sudden the probability aspects of this are actually being made explicit. So for instance, when we label things now, we'll give a probability threshold of what this might be. Is it 70% accurate? Is it 80%? Is it 85%? And then all of a sudden now we've pushed the decision from the software just tells you it's either A or B to you need to now make a judgment call on using this information. So going to your strong and AI point, which I think was a good topic to sort of go down, one of the big shifts is AI to us, a lot of the work going on right now is in decision support.
Okay.
It's really more about enabling people to make decisions as opposed to the big fear, which is giving full control to the system. There are a set of scaled AI. If you look at the AI market today, right, what is the sort of largest and fastest growing part of the artificial intelligence market, so to say, products-wise? It's actually RPA. It's the forms processing piece. Now, what's ironic is that AI. Yeah, please.
What's that acronym?
Robotic process automation. So it's basically, think of a system where you have to human fills out form 1, fills out some of the same information in form 2, form 3, form 4. Right. Okay. I had to do that when I onboarded the DoD. Like 15 of these, same pieces of information.
15, it's down.
15, all right, great.
It's only 15?
15, 20, 30. If I could just enter it once and then it goes and punches it in 15, 20, 30 different times. I'm still filling out forms now. Every week there's another one. That's an example where back in the 80s and 90s when I was studying AI, RPA was not considered part of AI. What's happened is AI itself has gone through sort of mergers and acquisitions and pulled out parts of statistics and other stuff to be called AI. So if you want to see like really, really fast AI successes, a lot of those successes are in things like natural language processing, image recognition, RPA, stuff that is scaled.
Okay.
And stuff that's sort of at the margin is things like object detection, and then things that things that you're doing, for instance, is way out there. But I think those are kind of the two big sort of ways to think about this problem.
Okay, so in relation to this, sorry.
Go ahead. Go.
Yeah.
I love hearing your thoughts. It's fine.
In relation to that, then, don't you think that the real push for explainable AI is essentially trying to figure out how to represent the certainty or confidence estimate of that AI decision to the consumer of that information?
The problem is that the number, they want to understand how the number is computed.
Well,
and the algorithm behind it and everything. So, I mean, when you ask somebody that question, the question becomes, well, just give me the number, but then explain the number to me. And of course, the number is not explainable easily.
That's right.
Then it gets down to, then you have to start giving them the parameters of the training and the algorithms for building the model. Then it gets down to, well, then you have to give me the inputs into the data. And then it's like turtles all the way down, and then you end up with that problem.
Or you can tell them that they're asking the wrong question.
Okay.
Which is to say that what we try to do instead is say that if you overall are trying to create a piece of technology, I'm going to use technology general but if you're trying to do that, then what the human really wants, the user really wants, is to have some estimate of that piece of information, much the same way that they have estimates of other humans, right? So there are humans in your environment that you think are sketchy, and you don't trust a thing they say. Maybe not in your work, but And then there are other times, right, where you just, you have more confidence in something, right, because you build it over time. So I really am just trying to get the world at large to try to rethink whenever someone's asking about explainable AI, and instead of keep thinking that what we need to do is find sophisticated ways of doing visualization of the algorithm and the parameters, I think we need to just start thinking, let's change the question to say, what is it that you actually are trying to build your trust of this data on, right, to use a loaded term.
The problem. Okay, go ahead.
Yeah, so
There's a little bit of an issue with that, though.
Try to get them to fight.
So,
Come on, Brian.
so in our space, we are a heavily regulated part of the government. We have to protect civil liberties. We have to maintain an appreciation for objectivity with our policymakers, and then part of all that is also being able to explain how we come up with the insights we come up with. So we have something called the Intelligence Community Directive 203, and that is a direction by the Director of National Intelligence that says, here's how to write an intelligence product that meets certain standards, which include things like the visuals you use in the product or the accuracy of the product. And as part of that, we have to write a little paragraph that says, here's how I came to the conclusions I came to, and has a confidence statement that goes along with that. So for us in this space, this is very different because we're talking, traditionally, we would take a tall stack of papers and make it a small stack of papers. I reviewed a product not too long ago where the source summary statement said they were evaluating 6 million data sets. I'm not going through 6 million data sets, right? It was an impressive piece of work, but it is challenging our understanding of how do I explain in a paragraph how I came to that insight. That is tough. So what kind of hits home for me is that when we start talking about what explainable AI is, for us, it's a little different. I need to understand it algorithmically. I also need to understand how the analyst, he or she, decided to interpret that. And how was that then put into an intelligence insight I can deliver to a policymaker?
Yeah, I didn't mean to imply that there's only one way to do it. I think this is kind of an unsolved problem. The thing that I struggle with the point that you're making, or maybe this is the point you were making, is this. Just the other day, I'm, again, completely brand new to the DoD, so I had no idea how, for instance, targeting is done. How do you do targeting? So targeting, for those, I'm sure everybody here, part of the defense world here, knows how that's done, but I didn't. It's something called a JPITL is the output. So the JPITL is this basically order of targets to be taken out that a commander issues and says, okay, do 1, 2, 3, 4, 5. Then what you do is you pair resources that you have, like a plane with a munition, to a target. Okay, so didn't know that. Now the situation is that this was the way things are done. We have this order, we run an AI. So the idea is, how do you AI enable something like that? Well, if you actually really step back and think about it, the problem is that the JPITL actually should not be an input into the system. It actually should be an output.
Output, yep.
Okay. But nobody was thinking about that because this is the way it's been done.
Yep.
And going back to the point that you were making is that I fundamentally don't want to now build systems where a cohort of kernels who've been trained exactly the same way all of a sudden now only agree with decisions that the machine is spitting out that gives them a confidence that other kernels would be making the same decision. And maybe that's not the point you were making.
It's a reasonable interpretation,
but the
it's not my
point is that we fundamentally, the whole game here is taking the knowledge and information, but figuring out the entire solution space. Because according to doctrine,